Hello everybody and welcome. Today we are going to be talking about comparing angles and some angle vocabulary. So after the end of this video, you should feel comfortable with some new angle vocabulary terms and being able to look at some angles, compare them, and classify them based off of the different types of vocabulary we go over today. So a few vocab words today. We're going to be looking at 3 or 4 new ones, which might seem like a lot, but if we can get these definitions down and get them down solid the first time through, we're going to be in really good shape. So the first thing that I wanted to actually start off with today, like we always do, is an applied example. So we're going to be taking a look at, it's called like a scissor lift. You can kind of see that the shape on the bottom here, they call it a scissor lift because, again, it kind of looks like scissors almost, like it kind of goes up and goes down and condenses into itself. So pretty commonly used for motorcycles. And I know that maybe some of our auto tech labs might have seen this used, kind of like an older style lift for some cars. And within these lifts, what you're going to see is there's a whole bunch of angles. So here's an angle, and again, seeing just a whole bunch of angles on the bottom. And the big reason why I'm bringing this up for today's lesson is because if we are not careful with these angles, if we're constructing something like this or even just putting it together and we notice something that's off, it's really important to keep balance and to be able to know if angles are the same or different. And the reason why that's important here is because if we're seeing these angles that are in the center, so like right here and right here, if these are different angles, and especially on the other side as well, we're going to have an extremely unbalanced load. And if you're working at or near this, you could find yourself maybe underneath it. So an important idea today when we're constructing things and just basically looking at some shapes here, again, important to see when angles are the same, when they're different, and when to know basically if it's a problem or not. So what we're looking at today is important for this, and hopefully we can see that application. And we're going to go through some vocab terms now. So to start off, we are going to go with adjacent angles as our first word. And again, there are quite a few terms, but just know if we keep these down and we keep this in our study guide, we're going to be in good shape. So don't feel overwhelmed, just take it one step at a time. So adjacent angles is the word. And what we define these as is angles with a common vertex and side, not or, but and side, but no common interior points. It's a really fancy way of saying, okay, so this vertex is common with multiple angles. They have a side that's in common, but nothing else. So it's basically just saying these two things are in common, but nothing more. So if we were to like draw a line like this, that's an example of angle 1 and angle 2 are adjacent angles because this side is in common and this vertex here, that is also in common. So those two things together make angles 1 and angles 2 adjacent. So angle 1 and angle 2 are an example of adjacent angles. Okay, so I put the guided notes on the bottom here. And again, a little bit of a repeat from what's above, but if we have this in multiple ways, it might help with multiple ways to understand. So adjacent angles are two angles that lie in the same plane. So they're in the same dimension, basically. They have a common vertex. They have a common side, but no common interior points. So that's just a really fancy way of saying that, for example, if we were to look at, let's see, this angle ABD, and let's say, I'll do this highlighted, an angle CBD, we could say that, okay, those two look like they are sharing a vertex. Looks like they have a side in common and nothing else, so that works. A non-example, so something that wouldn't work, so I'll write it here. Not adjacent would be angle ABD and angle CBD. And if we take a look at this, what we would see is that ABD is like this, CBD is like this, and they are sharing this interior. So looking at the inside of this here, we're seeing and I'll do this in a different color, all of this region in here is shared between the two, and we can't have that. They have to have their own separate independent spaces. So if we look at this one right here, the green has its own space, there's no overlap. The purple has its own space, there's no overlap. But here, we see that the purple and the green overlap in that point there, so that's not okay. So basically they can't share any of their middles, but they share a vertex and a side, and that's it, nothing more. So that's adjacent angles. We're going to move on to our next vocab word now, which is vertical angles. This is a bit of a actually shorter definition, which is nice. So I'm going to write that on in. So vertical angles, and these are two non-adjacent, so they don't share a side. So two non-adjacent angles formed by intersecting lines. So the easiest way to draw vertical angles is just to draw a line, draw one that intersects it, and know that if we're looking at 1, 2, 3, and 4 right here, they are not adjacent. So for example, vertical angles would not be 3 and 4, because 3 and 4, those two are adjacent. They share this side right here. Vertical angles are like on top of each other. That's the way that I kind of think about it. So I'll go actually back to highlighting here. I'll just choose a new color. So 4 and 2, directly on top. They don't share any sides. They do share a vertex though. So those are vertical. And then let's do it in another color. 1 and 3 are vertical. So our pairs would be, we would have 2 and 4, and we would have 1 and 3. Okay. All right. So our vocab words here. So two non-adjacent angles formed by two intersecting lines. And again, we can see an example here. This one works. Two intersecting lines. There's one, and then there's two sets of vertical angles. Here, this is one line, so line AB works. This is great. But again, we're seeing that these are just segments, so they're not extending through. We would need this to extend through to have vertical angles, or we would need this to extend through. So we don't see angles on the other side. These are two other lines, so that's line 2, that's line 3. So too much going on here. It's not crossing through, so we don't have vertical angles in that example. All right, next vocab word is linear pair. And we define linear pair as adjacent angles with non-common, so basically the side that they don't share. Again, I can't write today. Sorry about this. So non-common sides that are opposite rays. And that's an old vocab word that we have done actually this year. Remember, opposite rays are, it's more or less a line, and they just extend out. So if we add A, B, and C, AB and BC are both opposite rays because they share the B, but they extend in different directions. So we need to have opposite rays in order to have a linear pair. So it's basically on a line, they are collinear. So I'll write that on the side. So A, B, and C, collinear. And then we need to have our shared side. So I'll make it right here, make that point D. So our linear pair would be angle ABD and angle DBC. So again, here we are, and here is our shared side. And the important thing is, again, the non-common side is a line, basically. So this is our non-common side in yellow. That's a line. It works. We're happy. So again, a pair of adjacent angles whose non-common sides are opposite rays. So again, look for those opposite rays. Look for basically a line that joins them together. We got that here. We're happy. And again, a non-example, this is not a line, so we're not seeing those we're not seeing our opposite rays there. So that won't work for our linear pair. All right, last vocab word. And again, I know we have a lot today, so I'm sorry. But our last vocab word before we move on. So perpendicular lines. You've probably seen this before. So hopefully a little bit of a review. So this is when lines, segments, or rays intersect to form right angles. So an example here, we could have a line and we could have a ray coming out of it. And as long as this is a right angle, that is perpendicular. And our symbol for perpendicular is actually that. So that is our perpendicular symbol. Another example, you could have a line like this and a line like this. And if we have a right angle, again, these would be perpendicular lines. So they actually intersect to form 4 right angles. I think these notes might have got cut off a little bit, but that's okay. Yeah, and that's work. And they also intersect to form congruent adjacent angles. So what that's saying is the angles that are next to each other, like 1 and 2, these are the same. So the measure of 1 is also 90 degrees if it is perpendicular and it is adjacent. Segments and rays can be perpendicular to other line segments and rays. So for example, the ray that we had up here, if you see that up top, that ray is perpendicular to a line. So any combination of these things, as long as they intersect at a right angle, we're happy. The right angle symbol in the figure indicates that the lines are perpendicular. And the symbol, like that, kind of like an upside down T, is read perpendicular to. So a couple examples there. Perpendicular lines, a lot of vocab for this one, but I think hopefully perpendicular lines is one that we might have seen in the past. And again, if you need help with any of these 4 vocab words, definitely don't hesitate to reach out. We are here for you. We know that this one in particular, we have quite a few new things that we're doing, but it kind of all applies to the same types of diagrams, which is why we're doing multiple at once, because they all come up. So if it's not one of them, we have to know which other example it is, which is why we have a couple more today than we might normally have. All right, so we'll go through a few examples here before we go on. And let's start off with our first one. So a little bit of algebra solving based off of these definitions. So we need to make sure that KO is perpendicular to HM. So we need some right angles here. So first let's find KO and highlight it. And we need HM to be perpendicular here. So we know that our angles, and I'll highlight this in a different color, we need this to be 90 degrees, we need this to be 90, we need this to be 90, and we need this to be 90. So it looks like our algebra term here, 3x and 6 and 9x, those two together have to equal 90. So it looks like we have to add up 3x plus 6 and 9x together to get 90 for this to be true. So a little bit of algebra here. Let's put our like terms together. So 3x and 9x, those are similar terms. We still have our 6, our constant that we need to bring down. We'll continue solving this here. So we're left with 12x on the left side, 84 on the right. Divide that out, and we'll get x equals 7. So if x equals 7, then we'll see that that angle will be 90 degrees. So an example of solving with perpendicular lines, and you're going to see a very similar example for number 2. So I'll leave that one open for us to complete. And next up, this is basically applying all the vocab. So what I would say is if you should be taking notes as we're going through and writing these definitions down. And if you have these 4 definitions in front of you, we want to make sure that we're basically doing a quick vocab check with all these points. So coplanar means we're all on the same plane. Can we assume that? I don't see any lines going out of the plane. I only see this in 1 dimension, so I'm happy. That looks good. Is P between L and Q? They are on the same line, and I'll highlight that here. So again, this looks good. So this is kind of a little bit of a review check here. So again, carefully go through this, evaluate them one at a time. You might see some review stuff from maybe 1.1 or 1.2. So some earlier lessons here, but this example will be pretty comprehensive for you. So just go one at a time and see, does it work, does it not work? And if you're unsure, just write an explanation as to why you put what you chose. So if you're not sure in any of them, just explain your logic and you'll be totally fine. All right, our last example for this video, we're going to be looking at, again, another quick check here. So our first one we'll do, and I'll leave B and C for you. So V, Y, T, V, Y, T. And we need to see, is this a 90 degree? So if we look here, it might be kind of hard to see, but that right there is a 90 degree symbol. And we also know that this is a straight line. So if that is the case, then in order for this to work, that actually is true. So we would say that if this is 90 degrees, that means that ray YV is perpendicular to our line XT. And if that is the case, then yes, VYT equals 90 degrees. That is true. So that is my reasoning for why that is a true statement. Okay, so we're seeing again here, and I'll highlight this again. We're saying that this ray is perpendicular to the highlighted line because they drew in that 90 degree symbol. So because that's true, I know that the angle that we drew out must be also 90 degrees. Otherwise, it wouldn't be perpendicular. All right, so some examples there. A couple of questions for you to just do for check for understanding. We will take some dedicated time in class to go over these examples as well, so don't feel too stressed. But try to keep track of these vocab terms, try to keep things organized, and we're going to be in really good shape. So thanks for listening, everybody. Again, as always, questions, reach out to myself or Mrs. Gossett. We are here.